Ever wondered how data is managed efficiently in real-time applications or while handling large files? Well, the secret sauce is a concept known as streams. Streams in internet programming are abstract interfaces that handle the continuous flow of data. They're like the delivery service of the digital world, transporting data from one point to another. What makes streams so special? They allow for the processing of data as it arrives, rather than waiting for the entire dataset to be available. This makes streams the perfect tool for dealing with large amounts of data, real-time processing, or when data is being transferred over a network. It's like getting your online shopping piece by piece, instead of waiting for all your items to arrive at once. Now that we have a basic understanding of streams, let's delve into the different types of streams. There are 4 main types of streams in internet programming. Let's dive in and understand each one of them. Firstly, we have readable streams. Imagine a bubbling brook of data flowing from a source, and you're there with a bucket, ready to catch and read that data. That's what readable streams are all about. They allow you to read data from a source, like a file or a network request. Next up, we have writable streams. Flip the scenario around, and now you're the one pouring data into the brook. Writable streams enable you to write data to a destination. Whether you're writing data to a file or sending it off into the vast expanse of the internet, writable streams have got you covered. Then, we have the best of both worlds, duplex streams. These streams can both read and write data. Think of it like a two-way street, where data can flow in both directions. An excellent example is a TCP socket connection, where data can be sent and received simultaneously. Last but not least, we have transform streams. These are a special type of duplex stream. But what makes them special? Well, they can transform the data as it flows through. Imagine a stream flowing through a filter, changing the water's color. That's what transform streams do. They take input data, apply a function to it, and output the transformed data. A practical example is a zlib stream, used for compressing or decompressing data. So to sum up, we have readable streams that let us read data, writable streams that let us write data, duplex streams that let us do both, and transform streams that let us change the data as it flows through. So those are the different types of streams. Now let's talk about how data is handled in streams. Data in a stream is handled in pieces known as chunks. Now, you might be wondering why chunks? Well, imagine trying to drink from a waterfall. It's not only impractical but also a bit dangerous. Instead, it's much easier and safer to drink water in sips, or in our case, chunks. This is precisely how streams in internet programming handle data. Instead of consuming data all at once, it's broken down into manageable chunks. In the world of Node.js, these chunks are typically buffers or strings. Buffers, in simple terms, are temporary storage spots for data being transferred from one place to another. Strings, on the other hand, are sequences of characters. But the most important thing to remember here is that these chunks allow us to handle large amounts of data efficiently. Now let's move on to asynchronous processing. As the name suggests, asynchronous means not happening at the same time. In the context of streams, this refers to the ability to process data as it arrives, without having to wait for the entire dataset to be available. This is a significant advantage when dealing with large amounts of data or real-time processing. For example, let's say you're watching a video online. Without asynchronous processing, you'd have to download the entire video before you could start watching it. But with asynchronous processing, you can start watching the video as soon as the first chunks of data start to arrive. This is the magic of streams in action. Also, it's worth noting that streams inherently support asynchronous operations. In Node.js, streams use events to handle asynchronous data processing, making them non-blocking. This means that other operations can continue without waiting for the data transfer to complete, maximizing efficiency and performance. That's how data is handled in streams. But what happens when data is sent faster than it can be processed? That's where backpressure comes in. Backpressure occurs when the data source sends data faster than the destination can process it. Imagine a highway with a toll booth. The cars are the data, and the booth is the destination. If cars arrive faster than the booth can process them, a backlog forms. This is backpressure in action. Now, in the world of streams, backpressure has serious implications. It can lead to data loss, memory leaks, and it can even crash your application. But fear not, streams have a built-in mechanism to handle backpressure. When the buffer capacity is reached, the source stream is paused until the buffer is emptied again. This is like telling the cars to stop coming until the toll booth has processed the backlog. So managing back pressure is a balancing act, ensuring that data flows smoothly between the source and the destination without overwhelming the system. Back pressure is crucial for maintaining data integrity and application stability. Now let's look at some practical uses of streams. Streams are incredibly versatile and find use in a variety of situations. They are a powerful tool in web development, enhancing the efficiency of data handling and the performance of applications. Let's delve into some practical uses of streams. First, handling large files. Imagine you need to process a hefty data file. Instead of loading the entire file into memory, which could potentially crash your application due to memory overload, streams allow you to read and process the file in manageable chunks. This is not only memory efficient, but also enables your app to remain responsive and performant while processing the data. For instance, Node.js uses streams to handle file read and write operations, making it an excellent tool for working with large data files. Next, consider network communication. Data being sent and received over the internet or between processes often involves streams. The data is broken down into chunks and sent through the stream, allowing for continuous communication without the need for all data to be available at once. This is essential for maintaining the flow of information in real-time applications. An HTTP server in Node.js, for instance, uses readable and writable streams to handle requests and responses, allowing it to manage network communications efficiently. Lastly, streams shine in real-time data processing. Think of a video or audio streaming service. The data can be processed and forwarded as it arrives, providing a smooth user experience without delays. This is made possible by the continuous chunk-wise processing of streams, which keeps the data flow steady and manageable. These are just a few examples of how streams can be used. They're invaluable in handling large amounts of data, managing network communications, and enabling real-time processing. But like any powerful tool, they need to be used wisely. Lastly, let's talk about some best practices while using streams. Using streams can significantly enhance the performance and scalability of web applications. But to truly harness their potential, it's vital to follow certain best practices. Firstly, error handling. Streams, especially in an asynchronous environment, can throw up exceptions. When these aren't handled properly, they can crash the program or cause memory leaks. So always listen for the error event on streams and handle it appropriately. Secondly, the proper closing of streams. It's important to ensure that all streams are properly closed after their use. Leaving a stream open can lead to memory leaks and other performance issues. It's like leaving the tap running. It won't flood your house immediately, but over time it can cause a mess. Thirdly, the use of piping. Piping is a powerful feature that allows you to manage the flow of data from a readable stream to a writable one. It's like a relay race, where the baton is passed from one runner to another. When the data source is faster than the destination, piping automatically manages the back pressure, ensuring the destination isn't overwhelmed. So to recap, streams in internet programming are abstract interfaces that manage the continuous flow of data. They come in 4 types: readable, writable, duplex, and transform. Data in a stream is handled in chunks, allowing for efficient processing. Streams inherently support asynchronous operations and manage back pressure to maintain data integrity and application stability. Practical uses of streams range from handling large files, network communication, to real-time data processing. Remember the best practices: handle errors, close streams properly, and utilize piping. With these tools in your programmer's toolkit, you're well equipped to handle the flow of data in your applications. Understanding and utilizing streams can significantly enhance the performance and scalability of web applications. So keep streaming.